After ISRO succeeded with Chandrayaan-1, ISRO started a mission with Chandrayaan-2. Chandrayaan-2 mission is a highly complex mission, which represents a significant technological leap compared to the previous missions of ISRO, which brought together an orbiter, lander and rover with the goal of exploring south pole of the moon. The mission is designed to expand the lunar scientific knowledge through detailed study of topography, seismography, mineral identification and distribution, surface chemical composition, thermophysical characteristics of topsoil and composition of the tenuous lunar atmosphere, leading to a new understanding of the origin and evolution of the moon. Chandrayaan-2 Orbiter is capable of communicating with Indian Deep Space Network, IDSN, at Yalalu as well as the Vikram Lander. Orbiter weighs 2,379 kilograms and has a power output of 1,000 watts. Lander, Vikram weight of 1,471 kilograms and electric power generation capability of 650 watts. The lander of Chandrayaan-2 was named Vikram after Dr. Vikram Sarabhai, the father of the Indian space program. It was designed to function for one lunar day, which is equivalent to about 14 Earth days. Rover, Pragyan weighed 27 kilograms and had an electric power generation capability of 50 watts. Chandrayaan-2's rover was a six-wheeled robotic vehicle named as Pragyan, which translates to wisdom in Sanskrit. After the injection of Chandrayaan-2, a series of maneuvers were carried out to raise its orbit, and on 14 August 2019, following Trans-Lunar Insertion (TLI) maneuver, the spacecraft escaped from orbiting the Earth and followed a path that took it to the vicinity of the Moon. On 20th August 2019, Chandrayaan-2 was successfully inserted into lunar orbit. While orbiting the Moon in a 100 km lunar polar orbit, on 2nd September 2019, Vikram Lander was separated from the orbiter in preparation for landing. Subsequently, two de-orbit maneuvers were performed on Vikram Lander so as to change its orbit and begin circling the Moon in a 100 km x 35 km orbit. The orbiter placed in its intended orbit around the Moon will enrich our understanding of the Moon's evolution and mapping of the minerals and water molecules in polar regions, using its 8 state-of-the-art scientific instruments. The orbiter camera is the highest resolution camera, 0.3 m, in any lunar mission so far and will provide high-resolution images which will be immensely useful to the global scientific community. The precise launch and mission management has ensured a long life of almost 7 years instead of the planned 1 year. What happened to the Vikram Lander during landing? What is the reason behind it? Chandrayaan-2 was ISRO's maiden attempt at achieving soft landing on the lunar surface, but the mission failed when the organization lost contact with the lander 400 meters before the landing. Vikram Lander descent was as planned and normal performance was observed up to an altitude of 2.1 kilometers. Subsequently, communication from lander to the ground stations was lost. The lander's velocity was supposed to be reduced from 6,000 km/h to 0 km/h in 4 phases to be carried out within a span of 15 minutes. However, during the second phase, the velocity was not reduced as desired, which the third phase could not handle, said ISRO Chief K. Sivan in his first official statement on the failure of landing Vikram. Had it gone right, India would have become the 4th country, after the US, Russia and China, to carry out a successful landing on the lunar surface. India would have also been the first country to successfully carry out a landing on the south pole of the Moon.